Hello, welcome to a new section of the course, Data Manipulation. In this section, we first cover how to create a data.table. We then introduce operations to manipulate, join, and process data. Moving on, we present how to use deployer to perform fast data aggregation. In advance, with the help of the chaining operator, we can quickly perform descriptive statistics with SQL-like functions on a given tabular dataset. Now we'll move on to the first video of the section, enhancing a data.frame with a data.table. In this video, we'll show how to create a data.table in R. Most R users will agree that data frames provide a flexible and expressive structure for tabular data. While data frames are effective for small datasets, they are not ideal to use when processing data that is larger than a gigabyte in size. Additionally, it's not easy to summarize data within the data frame itself. We need to load an additional package such as PLYR or Reshape2 to perform advanced aggregation. Therefore, we would like to introduce how to use data.table and deployer to perform descriptive statistics. We first illustrate what these two packages do. Data.table. This is an extension of data.frame. It provides the ability to quickly aggregate and process large datasets. Additionally, it provides a much more readable and less confusing syntax compared to data frames. Deployer. This provides users with a SQL-like function so that we can quickly aggregate and summarize data from various sources. These two packages can help users quickly and easily generate descriptive statistics from any given tabular dataset. When you process a dataset that is a gigabyte or larger in size, you may find that a data.frame is rather inefficient. To address this issue, you can use the enhanced extension of data.frame, which is data.table. First, we have to download the purchase_view.tab and purchase_order.tab datasets from these links. I'll show you the links. This is the first link. Click on Open, and make sure you save this file in the RStudio directory. You know how to find the directory. The next file is also downloaded from a GitHub link. You have to click on Download. Now let's start. We will install and load the data.table package using these commands. You have to give the install function with the name of the package, then load the package using the library function. Next, we can create an R data frame using read.table. Let's do that. We will now see the dimension of the purchase that we have just created. This is the dimension. 54,772 in 6 variables. Then we convert the data.frame into an R data.table. We will call the class function. You can see it's converted. Alternatively, we can create a new data.table. You can see the table here. There are 3 columns: product, price, and category. Instead of using column names function to change column names, we can use the setNames function. Additionally, we can use the fread function from the data.table package to read data. Moving on, let's examine the data loading speed of the data frame using system_time function. And you can see, on using the read_table function, you can see the time that is used this much. Now let's compare the read performance when using the fread function. Here's the function. Here you can see the time difference. Similar to how we examine data from data.frame, we can also use the dim and scr functions to examine the structure of the data.table. Here you have the dimensions and the structure function. You can see the output, that is number of observations and number of variables. Besides using the fread function from the data.table to read datasets that contain millions of rows, we can consider using another reader package to read flat files into R. The readr function is implemented in C++ and RCPP. As a result, the performance is slightly slower than fread. However, it's still a better choice than read.csv or read.table when reading a large amount of data from flat files. You can use this command to read purchase_order.tab into an R session. First, install a package called readr. In your case, it'll show a successful installation. We add this code. And here we can see our output. Let's call class function, and here we can see the output here. In this video, we created a data.table successfully. Great! In the next video, we will manage data with a data.table.